Okay, finally today we're building the AMD 7950X into ASUS's X670E-I board. Some chunky high-end GPU. I originally wanted a 4090 for this video, but I'm picky and I can't find the exact model or models that I want locally yet. So I just have a couple chunky GPUs here as placeholders, and we're cramming that all into this Coolermaster NR200P ITX case, air-cooled with a lower profile Noctua air cooler. This should be one heck of a system, a super dense brick of computing performance, although we might need to tweak a few things here and there in the OS after it's built pertaining to power and clocks, but I guess we won't know until we've tried, so let's build. Let's put it together. I've been putting off this video for too long. Life's just been crazy. I got these parts like the day of the launch, except for some of these parts are used. But all the new parts I got like the day of the launch, the day after the launch. I did build a test bench and play with these new parts for a couple days here and there, time permitting, because I was so excited about the uplift in performance. But it's finally today that I get to actually build them all into a system. So let's start with the case. We're gonna be using this Coolermaster NR200P. I got this case like a year ago off Tristan because he had it as a spare. And I really liked how it looked, especially with the mesh side panels. It kind of looks performance-y, you know? And why white? Well, that's what Tristan had. And it doesn't hurt that the white cases show up better on camera too, especially when filming inside. Also, if we look down here in the GPU department, we can see a big old triple slot GPU expansion area, which is a good thing because we are going to be using some chunky high-end GPU. Wish it was a 4090, but I already explained that. We're gonna need as much room as we can get in the bottom of this case. So yeah, anyway, now this thing is fully torn down, we can use our installation manual to install parts in some well thought out order that's usually important for building in ITX cases. Starting with motherboard. We have ASUS's ROG Strix X670E-I gaming Wi-Fi board. We just did a detailed overview of this board because there was a plethora of interesting engineering choices and features for this generation of high-end ITX board from ASUS. So click right up here for that video. I'll also make sure to link it at the end of this video, as well as in the video description down below. So if you want to check that out after this video, of course. But before just slapping the -I in here all willy-nilly, we should probably deck this thing out because accessing it once it's installed in the case will be an unnecessary headache. And if my past ITX builds are anything to go by, we don't need to go looking for any extra trouble because I'm sure trouble will find us sooner than later. So first up, 7950X, the latest and greatest from AMD. For the record, if I was trying to build a small form factor, purpose-built gaming PC, I would not recommend the CPU under 99% of circumstances. I'm just using it in this case because I'm just curious of what happens, aren't you? So now we come to one of the more confusing parts of this, honestly. I have the manual out so I can reference to try to make sure I'm doing the right thing here. But we need to install our M.2. I do plan on using this build for going to LAN parties. Yes, I do have a small group of friends that still try and get together when we can in person and game an entire day away. So I've gone with this 2TB MP600 Pro NVMe from Corsair. This will allow me to carry a good variety of games installed locally on the system. It'll be blazing fast for updates and loading screens, as well as just keeping the whole system nice and snappy. It's worth noting this is a Gen 4 drive, and this board does support Gen 5 NVMe storage, as well as Gen 5 on the PCIe X16 slot. And this is the part that was a little confusing. There's two slots here. There's a lower and an upper. This lower one here actually is the Gen 5 slot. Kind of makes sense because it's closer to the board, so you're not gonna risk as much signal interference as this big long riser that goes up to this top slot here. However, this is a Gen 4 drive, so there's no point of populating the Gen 5 slot down here. I can always put a Gen 5 drive in it later because they've actually designed this heatsink here to come off. Like you can take just the top off and access the top slot, or you can actually leave the top slot totally assembled and just remove a couple different screws and get to the bottom slot later. So for now, we're gonna be putting this Gen 4 NVMe in the top Gen 4 slot. First things first is we gotta free this drive from its stock heatsink here, because obviously that's not, well, I mean, like technically if we really wanted to, you could just install the drive like this and leave the front cover off. However, I'm gonna go for a little bit more aesthetics, and also there's definitely a height difference here, and put this on. So first thing we gotta do is free this drive from its stock heatsink, which apparently is a lot easier said than done because that thermal pad just totally ripped in half. I definitely did bend it a little bit getting it out, so hopefully it's okay. But let's clean up all this thermal paste and goop on it. So I won't lie guys, that was a pretty traumatic experience taking this heatsink off. This is a really well used drive, so it's gone through many thermal cycles. I don't know if that has anything to do with how hard that heatsink was to take off, but I had to put like an uncomfortable amount of pressure on this thing, and it definitely made some unpleasant noises. So fingers crossed on this one. For future reference, I think if I ever know I'm going to be installing an M.2 under a heatsink, sometimes you can buy like different heatsink versions or non-heatsink versions, like they come with or without the heatsink. Maybe think ahead and get the one without the heatsink, just so you don't have to put the drive through that much stress. Yeah, we'll fire it in for now, see how it goes. This part's easy enough to change later if there is an issue with it. This thermal pad on the back here, you gotta make sure you remove this blue plastic protective coating. And if this pad does rip on you in the future, it's a 1.25 millimeter pad if you had to go ahead and replace that. I really hope this drive's okay. With that traumatic experience all over, we have RAM. I have here 32 gigabytes of Corsair Vengeance DDR5 RAM at 5200 mega transfer per second speed. Although I wonder if we can get that up a bit. I have zero experience overclocking DDR5 RAM, but I did notice on the package here it says onboard voltage regulation, which all DDR5 modules have, for more controlled overclocking. Let's be honest, I bought this mainly because it was on sale and it was a good deal here locally. Take your peels off, enjoy your things. Don't be keeping it nice for the next guy. And normally I would install the CPU cooler now, but I think I might wait, only because I don't think I'm going to be able to get at these other little connectors around the CPU socket area afterwards. So holy moly, that's heavy. So now this metal block is complete. It's just 4 screws to hold it into the case. The IO shield is built in, so there's no worries there. So now the mighty installation manual is calling for the installation of the power supply, so we'll go ahead and get that in there. So we're using this Corsair 750 watt SFX PSU. This particular model is platinum rated for its efficiency, which is probably the reason why I bought it. Used, of course, because why pay for something full price if you don't have to? Now, I know there's at least a few of you out there who are going to be like, whoa, hold up, Kyle, you are crazy. You can't use a measly 750 watt PSU in a juicy build like this. We'll see. I'll slap a power meter on this thing later on in the video and we can see what it's actually drawing from the wall. And then maybe we can figure out how crazy I really am. Together. Whoa, shirt change. Yeah, it's been a couple days since I've worked on this. I underestimated how much time I would need to put this thing together, apparently. I wanted to get it all assembled last time I was filming, but I didn't quite get that far. You'll notice things look just a little bit different today. So I found out that in order to actually do the cable management for this thing, I basically had to build it more or less because the GPU sits in this area down here. Unless those cables are all the way fully up, these cables will actually stick into this upper fan. So this top fan ended up sitting against those cables and that would not have been good if I turned it on. So I had to kind of assemble this thing essentially in order to get the cables put into their proper locations. The good news is I'm pretty sure all the hard work's done and I can start throwing this thing together. One other thing to note is I did manage to snap off the locking tab on this NVIDIA 12-pin connector. Not really that big of a deal, I guess, unless maybe it wiggles out over time as I carry the case around, but I can always swap that out later. So with all those headaches and things out of the way, let's just get back to building this thing. Moving right along. If you're lucky enough to be blessed with owning a dual slot card, you have 2 mounting options. You can mount here or here. However, we are not lucky enough to be blessed with a reasonable sized GPU today for this build, and that's kind of the whole point, is to see how much we can cram in here. So we're going to be stuck using this triple slot traditional mounting area down here. And by having the GPU down here, that's going to leave space for our Noctua air cooler, which, if I've done my research correctly, should fit in this case in a most satisfying way. I've already routed all the cables, which was a combination of putting in hardware and taking hardware out to make sure everything would fit in here properly. So I think we are okay to install our CPU cooler. Let's figure out also if this cooler will work with AM5. I just realized that if this M.2 does indeed end up being dead, I'm probably gonna have to remove this cooler. Now for thermal paste today, we are going to use Kingpin KPX. Someone posted on my video for my fan shrouds I did for the Strix cards that KPX is not a good everyday daily driver thermal paste because it's prone to pump out, which is basically where the CPU and the cooler get hot and cold, hot and cold, hot and cold, and it ends up squeezing the thermal paste out from between the contact surface. I haven't seen any of that yet. I've been using this for a little over a year. Ever since I read that comment, it's kind of made me want to use this on everything just to see if I do ever get any sort of negative effects or anything from that. So now I'm curious to see if this top panel will actually fit on. So I don't know if you can see that on video. That's making pretty good contact with the CPU cooler. I might have to run slim fans up top, which would significantly reduce my cooling. I'm gonna try to take these fan grills off and see if that gives us enough room. Well, it's on, but I did see a little bit of movement on the CPU cooler when I snapped the top in, which is less than ideal because if I'm putting downward pressure on this, I'm gonna be making better contact with the bottom of the CPU than the top as far as like where the thermal paste actually is. It's gonna kind of pivot the cooler down. Now we'll have all the room in the world and then some. But the cooling will be no bueno. I'll think about that one more in a minute. For now, there's nothing else I need to access on the bottom of the board, so I don't see any reason why we can't put our GPU in. Okay, so it looks like I can fit this front fan in, which is good because it's going to offer a tiny bit of exhaust, nowhere near as much as we probably need. You know, I wonder if I have a Noctua PPC kicking around. Okay, so I have a 120mm Noctua PPC fan. This one does ramp up to 3000 RPM, so I mean, if I absolutely needed it, it's there. You know what? I'm going to allow it. I think it's putting a bit more of like a twisting force on it versus like a leveraging force, so maybe it's fine. And no, there's not enough room to fit a 120mm fan under this GPU. I could fit a slim, but then you're really starting to get into like how much is it actually helping? If it's rammed right up against this and it's rammed right up against the GPU, can it actually scoop the air and move it through the fan? So I just need the side panel for on here and she's done. All right, let me clean up this mess and get some shots of this thing and then we'll see if it turns on. This thing is quite heavy. Oh my goodness. Really? Okay, moment of truth. We'll find out if any fans are eating any cables or if that NVMe drive is dead or whatever else. So I don't know if you can hear that, but this bottom fan on the...
I lost my train of thought apparently while I was recording this, but what I was trying to say is the bottom 40mm fan that points at the M.2 heatsink on the motherboard is very noisy.
probably just doing memory training right now. This fan is also pretty much at full speed right now, I think, so we'll just let it work its magic. I did have one viewer who was asking me if the fans were loud on this X670E-I mini ITX board by ASUS. And I can tell you that one bottom fan, the one that's pointed at the chipset and the M.2 area, is just screaming right now. I can actually hear it over this Noctua PPC at full speed. Hey, there's a post. And that bottom fan stopped screaming in the motherboard too. Interesting. The storage drive is detected, so that's a good sign. F1 to run setup. So CPU sitting at 52 right now. CPU core voltage 1.456. I want to just put all the stock limits in place. How do we do that? Okay, so as far as I can tell, I've turned off all ASUS's performance-y, boosty type stuff, so it just should be running full stock. I did find in the BIOS there was control for the VRM fan, very limited control, but some control for the VRM fan. I did not find any control for the little screamer at the bottom, the M.2 and chipset fan. So I wonder if I can do that through the OS with some software or something. So there we go, I'm booted into the desktop. I guess I didn't kill the Corsair drive after all, which is amazing news. I don't really have anything installed on this right now that I can do a lot of testing and stuff with, so I think this is a great point to call this video. We did go over a lot of stuff with the build. I don't want the video to be too long. I will do a second parter where I actually do temperatures and get into everything else. Maybe we can check some of those other fan configurations and stuff. What are you guys thinking about this? Is this thing gonna work? Is it gonna cool? Worth a crap at all? Is it just too much heat in a little box? Get subscribed. You'll see when I drop the next video to do with all this testing, thermals and stuff. Check out the overview video we did for this X670E ITX board by ASUS if you haven't already seen it. I'll link it here at the end of the video. Toss a like on this video if you found it interesting, and I'll see you in part 2.